Some notes on Saturn. Saturn is within the concave Earth. That means it's very small, despite what these NASA scientists tell you. They talk about the Cassini spacecraft that supposedly orbited Saturn. Well, it's in the Earth. Not sure how far away it was, but it had to get past the thermosphere. So it had to withstand an intensive amount of heat. But I'm just going to make some notes here.
It was over except for a very turbulent zone and this little vortex that survived the encounter with the head of the storm. And we're still seeing effects in that band in Saturn's atmosphere in the north. Here's another view. This is in the near infrared, and the colors are different wavelengths. The blue is reflected light. You can see the reflected light coming from the rings. If you look at longer wavelengths, green is 3 to 4 microns, and here's the aurora at the south.
Okay, I don't think it's actually an aurora. This is an infrared light, which means it's not visible to the naked eye. It's picking up heat. That's what it's doing. It's not really an aurora. Auroras are happening within the concave Earth over the glass sky. The glass sky is the insulator for the solar wind to actually interact with the magnetic field that's exhibited from the northern and polar regions, the geomagnetic regions of the Earth. There's actually, what I think it is the Earth is actually below the Earth. The rind of the Earth is actually made out of metal, but at the top and the bottom, the poles, North Pole, South Pole, there's no metal there. So it's just continental crust, basalt, or granite that has been formed by water creating sedimentary rock. And so you have these lips, these metal lips at the top and the bottom, which actually is offset a little bit. Okay, the geomagnetic pole is offset from the actual true north and south poles. And the geomagnetic poles are antipolar, which means they are in direct opposition toward each other, which is different from just regular magnetic poles, which are not antipolar. So there's some kind of variance that's happening from beneath, from the metal rind, and to the surface. There's some kind of fluctuation or deviation that's happening. So, but when they tell you these auroras on Saturn or Jupiter, they're not visible with the naked eye. And I think it's just it's just heat. It's different type of energy. So it's not comparable to Earth's auroras. Earth's auroras are happening because plasma, okay, the glass sky is a vacuum tube. It's a vacuum tube up in the middle of the Earth. There's a vacuum tube. You have the electrons from the sun and interacting with the openings beneath the ground, the metal openings. If you watch my seismic wave video, you understand that. There's metal beneath the ground. They call it the Moco layer. So that's that.
Pole of Saturn, and the aurora here are a greenish color. That's telling us something in particular about the particle size, and also we have information on composition. And then you can actually see heat coming from the planet here as well in the reds and blues. As you look to longer wavelengths, you're no longer seeing visible light. You're actually seeing heat coming out from inside of Saturn.
It's not actually an aurora.
Another very interesting finding was that Saturn has something called Saturn kilometric radiation. It's a radio beam that rotates around.
Now listen, this is quite telling. A radio beam that rotates around the planet Saturn, okay?
About once every 10.5 hours. It's kind of like a lighthouse beam, and it sweeps across Cassini. You can see it sweeping across as it beams out there, making very strong signals. And when Voyager flew by, we thought, oh, we've got the rotation rate for the interior of the planet, something very fundamental in trying to understand Saturn. The problem was that, 20 years later, here comes Cassini, and the period's different by 6 minutes. And we know Saturn couldn't have slowed down. It's just too big.
Too big. It's too big. Well, no, it's actually not too big. It's very small. So there is a rotation rate decrease by 6 minutes over 20 years. So we're talking Saturn is probably, like I said before, it's maybe about 50 feet wide. 100 feet at the most. It's a tiny object within the concave Earth. Same with the other planets. Earth is not the planet. Earth encompasses the other planets. The sun and moon are tiny too. So Just another piece of evidence that shows. Also, too, looking at Saturn, you can just tell it's small. You look at the shadows that are going across the rings of Saturn. Okay, they're crisp. If this was like stretching over hundreds of kilometers, hundreds of thousands of kilometers, you wouldn't get that definition. Also, looking at the hexagon on the top of Saturn, you would not get that symmetry at that big, that magnitude. Okay, but if you're talking like 50 feet across, that's doable. It's doable to have symmetry in smaller objects. Saturn's very small. More later.